Every year, the world produces over 420,000 tons of snails. That's more than the weight of 300,000 cars. Imagine these slow creatures being transformed into delicacies worth up to €50 per kilogram, or their slime being used in cosmetics priced at up to €300 a jar. Snail farming isn't just a business, it's a billion-dollar industry. Want to know all the secrets? Stick around till the end. Picture vast fields where thousands of tiny snails crawl slowly among the greenery. These are snail farms, and they're more than just a thing. They're a serious business. Europe leads the world in snail farming, with most farms located in France, Italy, Spain, and Poland. The main species grown here are the Helix aspersa, or small gray snail, and Helix pomatia, known as the Burgundy snail. The idea of farming snails has ancient roots, dating back to ancient Rome. Think about it. The Romans were both gourmets and innovators. They were the first to cultivate snails on a large scale for food. How did it work? Romans built special snail gardens where they kept snails, feeding them herbs, fruits, and even wine. Yes, you read that right. They literally soaked snails in wine to make them more tender and flavorful. The famous Roman naturalist Pliny the Elder, who lived in the 1st century AD, wrote about snails being a delicacy at noble banquets. He even mentioned a Roman gourmet, Quintus Fulvius Lupinus, who established the first known snail farm in the 1st century BC. After the fall of the Roman Empire, snail farming was somewhat forgotten. But during medieval times, monks revived it. For them, snails were a convenient food option during Lent, as they weren't officially considered meat. Clever monks, huh? By the 19th century, snail farms gained popularity in France and Italy, where modern farming methods were developed. The French were the first to turn snails into a gastronomic brand now known as escargot. In the 20th century, snail consumption increased so much that industrial-scale farms became necessary. Today, we have entire industries, from food to cosmetics, all thanks to this ancient Roman idea. Isn't that fascinating? Every year, over 420,000 tons of snails are farmed globally, with Europe dominating the market. France, for instance, consumes about 30,000 tons of snails annually, half of which are imported. Imagine the scale. Let's start with the snail nursery. Farms begin by collecting snail eggs, those tiny white pearl-like balls. The eggs are carefully selected because the farm's success depends on their quality. To encourage breeding, farms create specific conditions. The air temperature must be around 70 degrees Fahrenheit, with nearly 100% humidity. It's like a paradise for snails. Farmers even use special systems to keep the air moist, ensuring the snail's comfort. The eggs are then moved to incubators, where tiny snails hatch a few weeks later, barely recognizable as the future delicacies. Surprising, isn't it? My friend once had pet snails, and they bred like crazy in any conditions. But here, with all this care, there are no guarantees. Perfection is truly the enemy of good enough. Let's take a closer look at how snails grow. Once they hatch, the snails are moved to open enclosures, special fenced areas on the farm where they can crawl freely. They're fed a mix of grains and vegetables like cabbage, carrots, or even lettuce. Snail care is a science. Farmers regularly check their health, provide plenty of water, and even protect them from natural predators like birds or insects. Fun fact, a snail can drink more water than its body weight. In some countries, snail farms play relaxing music to reduce stress. Snails can take up to 6 months to grow large enough for harvest. Their size and weight depend on the species and farming conditions. Harvesting snails is an art. When snails reach the right size, they are collected, often by hand. Each snail is carefully inspected to ensure it's healthy and high quality. In snail farming, healthy and high quality involves several key factors: physical condition, suitability for consumption, or cosmetic use. A healthy snail actively moves, stretches its body, and responds quickly to stimuli like touch. Sluggish or closed snails might be stressed or sick. Their shells must be intact, free of cracks, spots, or chips, a sign of sufficient calcium in their diet. Healthy snails should also show no signs of parasites, fungal infections, or diseases that could affect their viability. On average, a snail weighs about 1 pound, though the ideal weight varies by species. This is the optimal size for culinary use. Before processing, snails are kept without food for 3 to 5 days to clear their digestive systems, ensuring the product is safe. A snail's diet impacts the quality of its meat, so their meals consist of greens, fruits, and special mixes. High-quality snails have tender, slightly sweet meat. They must be raised without harmful pesticides or fertilizers, as they are highly sensitive to contamination. For cosmetic purposes, snails need to produce a sufficient amount of slime, known as mucin, but more on that later. This requires proper nutrition and farming conditions. Healthy snail slime is transparent, impurity-free, and rich in beneficial components like allantoin, elastin, collagen, and vitamins. Quality snails live for 3 to 5 years, which is crucial for sustainable production. However, on farms, they're usually kept for about 14 months. Modern snail farming emphasizes eco-friendly practices, no soil or water contamination, and an organic approach to feeding. A healthy, high-quality snail grows in ideal conditions, eats a balanced diet, and shows no signs of stress or illness. It's perfect for gourmet dishes or premium cosmetics. Collected snails are washed and sent for further processing. If the farm caters to the restaurant market, the snails are immediately placed in special refrigerators, where they enter a state of dormancy, a natural process allowing them to sleep. Globally, over 420,000 tons of snails are farmed each year, with France, Italy, Spain, and Greece being major producers. Snails move at less than half a pound per second, so to cross a football field, they'd need about 5 hours. But they can endure a 2-hour walk in the rain without a break, the equivalent of a marathon for us. An average farm raises anywhere from 100,000 to 1 million snails. Now, the exciting part. How do these slow creatures become delicacies? First, they're prepped for consumption, washed, cleaned, and boiled. Then, they're marinated, baked, or stuffed with delicious sauces. Did you know French restaurants love serving snails in their shells with a garlic butter sauce? It's their signature move. If food is clear, how did snails end up in cosmetics? It's all about the slime. It contains beneficial substances like allantoin, collagen, and glycolic acid that work wonders on the skin. In ancient Rome, slaves rubbed snail slime on their mistress's skin, believing it healed wounds and rejuvenated. In the 1980s, Chilean farmers raising snails for export noticed their hands became unusually soft, free of cuts or scars. This sparked the idea of using mucin in cosmetics. On specialized farms, snails are kept in comfortable conditions where they produce slime. This slime is harvested without harming the animals and used in creams, masks, and serums. They say this ingredient works miracles, rejuvenating skin and addressing imperfections. The snail slime cosmetics industry is worth $760 million and grows 10% annually. The biggest buyer, South Korea. The slime collection process may seem odd, but it's designed to be cruelty-free. There are 2 methods: manual stimulation and automated systems. In manual stimulation, farmers gently massage the snail's body or spray it with clean water and sea salt. The snail secretes slime as a natural defense mechanism. The collected slime is washed and sent for filtration. For automated systems, large farms use special devices. Snails are placed in containers where they are gently stimulated with water or air streams. The slime flows into a reservoir for collection. Afterward, the snails are washed and returned to their enclosures. They can produce slime again after a few days, ensuring the process doesn't harm them. The collected slime is purified, leaving only the valuable components. The resulting mucin is rich in collagen, elastin, glycoproteins, and other active ingredients. After processing, the slime becomes a raw material for cosmetics or pharmaceuticals. Snail slime is then used in high-end creams and serums that repair skin and treat acne. To produce 33 ounces of quality mucin, about 50,000 snails are needed. The snail market isn't just about food or cosmetics. In the European Union alone, it's a multi-billion euro business. 1 kilogram of snails can cost between 20 and 50 euros, depending on their origin and processing. Cosmetic products made from snail slime sell for 30 to 300 euros per jar. Forget everything you knew about fuel. Sugarcane bioethanol is ushering in a new era of energy. With technologies that automate every step, from planting to distillation, we're able to produce fuel that cuts emissions by 90%. In this video, we'll show you how simple sugarcane stalks could hold the key to an energy revolution. Don't miss out, this is a true breakthrough. It all starts with sugarcane. Sugarcane thrives best in tropical and subtropical climates with plenty of moisture and sandy or loamy soils. That is why tropical regions like Brazil, India, and parts of the United States are ideal for its cultivation. Before planting sugarcane, a soil analysis is performed to determine the potential of hydrogen and nutrient content. Specialized sensors analyze moisture, potential of hydrogen, and nutrient levels, automatically adjusting soil treatment. The optimal pH for sugarcane ranges from 5.5 to 7.0, and based on these readings, fertilizers are applied, usually nitrogen, phosphorus, and potassium. Modern tractors equipped with GPS systems are used for precise soil preparation. They can handle plowing, cultivating, and fertilizing with maximum efficiency. After preparing the soil, a simple variety of sugarcane is selected, one that is well suited for consistent yields. Automated planters sow the seeds at a distance of 3 to 5 feet apart and at a depth of 2 to 4 inches to ensure even growth. Workers use specialized sensors to monitor planting depth and row spacing, which increases efficiency by 20%. Next, drip irrigation is used. Modern irrigation systems are equipped with moisture sensors that automatically activate watering only when necessary, helping to conserve water. During the first few weeks, it is crucial to maintain adequate moisture for root development. Drip irrigation can reduce water usage by 30% while promoting better plant growth. Irrigation is controlled through programs that account for weather conditions, typically scheduled 2 to 3 times a week, depending on the weather. Harvesting typically takes place 12 to 18 months after planting, when the sugarcane stalks have reached their peak sugar content. It is important to conduct a sugar content analysis to determine the best time for harvest. Before the harvest begins, fields are assessed for the readiness of the sugarcane, taking into account plant maturity and the presence of any diseases. Once preparations are complete, harvesters take over. These harvesting machines are equipped with specialized heads that allow them to cut the sugarcane stalks without damaging the plants. The heads may use cutting mechanisms that operate by rotation or oscillation. Modern harvesters also come with sensors to monitor moisture levels and plant density, ensuring a more efficient and precise harvest. After harvesting, the sugarcane moves to the initial stage of processing, where it is cleaned and chopped. To prepare the raw material for extraction, the stalks are cut into short segments, about 6 to 8 inches long, followed by preliminary shredding. Shredded stalks are easier to extract juice from, making this step essential for increasing juice extraction efficiency. Specialized machines, shredders or hammer mills, are used, each with different cutting mechanisms such as teeth or knives. Shredders are equipped with cutting elements that ensure fast and even shredding of the sugarcane stalks, preventing irregular particle sizes. The processed sugarcane is fed into a shredding chamber where it is broken down into smaller pieces, typically ranging from 0.8 to 2 inches. This size optimization allows for ideal conditions for juice extraction. Once shredded, the cane particles are discharged from the machine for further processing. Modern biofuel production reminds me of my high school experiments. My parents were environmental activists in their youth, so awareness of ecological issues was practically instilled in me from birth. I was absolutely thrilled when I discovered that you could theoretically make biofuel from ordinary potatoes. It was such a blast, boiling up that potato mixture and then adding yeast. Unfortunately, I didn't have any special yeast, so I had to swipe some regular baking yeast from the kitchen. In the end, I left my biofuel to ferment for a few days, but somehow managed to forget about it for almost a month. Don't ask what I found in that jar when I finally remembered it. You're better off asking how many times I had to mow the lawn as punishment. But honestly, I regret nothing. It was a lot of fun. So where was I? Oh, right. Conveyors automatically transport the shredded sugarcane to the presses, reducing the time between preparation and extraction stages. During the extraction process, the maximum amount of sugar content is released, which is essential for fermentation and biofuel production. In modern industrial settings, extraction is done using large roller presses. Typically, multi-roller presses, 5 to 7 rollers, are used, which gradually apply increasing pressure to the raw material. The first rollers extract 60 to 70% of the juice, while the second and third stages allow for an additional 20 to 30% extraction. As each pressing stage reduces the moisture content of the material, the end result is a dry residue called bagasse, which is also utilized for energy needs. The extracted juice has a high concentration of sugars and moisture, but it also contains solid residues and other impurities that need to be removed. The juice is filtered and purified before fermentation. Filtration systems rely on automated cleaning processes, which monitor the juice composition and automatically remove solid particles and other unwanted impurities. The decanting and centrifugation processes are fully automated, efficiently separating the liquid from the solids. Speaking of bagasse, the solid residue left after extraction, it is used as biomass for energy production, burned to generate steam and electricity. I'm just amazed at how well thought out everything is. After filtration, the sugar juice is prepared for fermentation. It must be treated to create the ideal environment for the yeast, which will convert the sugars into ethanol. The juice is typically mixed with water to achieve the desired sugar concentration, which is usually around 12 to 18%. Special sensors monitor temperature, potential of hydrogen, and solution concentration in real time, ensuring consistency across all batches of juice sent to fermentation. Yeast, the biological catalyst of the fermentation process, is then added to the prepared solution. The yeast dosage is handled automatically, with precise control over the number of active cells in the fermenter. Modern fermentation systems use automated setups for yeast cultivation and regeneration, ensuring a steady and highly efficient process. Fermentation takes place in large tanks that provide the ideal conditions for the yeast. The process typically lasts from 24 to 72 hours, depending on the temperature, yeast type, and desired outcome. Not that long, right? The optimal fermentation temperature usually ranges from 86 to 95 degrees Fahrenheit, and automated systems maintain this range. Oxygen sensors regulate aeration levels because excess oxygen can slow down the conversion of sugar into ethanol. Automation ensures precise control of these parameters. Online monitoring systems measure sugar concentration, ethanol levels, potential of hydrogen, and gas exchange within the tanks. This data allows operators to predict the completion of the process and automatically adjust the temperature or oxygen flow to optimize the final product. Oh, we finally reached the final stage of producing biofuel from sugarcane. After fermentation is complete, the liquid in the tanks contains about 10 to 15% ethanol. The carbon dioxide released during fermentation is collected and can be used in various industrial processes, such as producing soft drinks or for refrigeration. The leftover yeast is also reused or repurposed for other applications. The resulting liquid, which contains ethanol, requires further purification and concentration. To achieve this, specialized filtration and distillation systems are employed, where the liquid is separated into ethanol and water. The filtration process is fully automated, with the liquid passing through multi-stage filters that remove solid particles and yeast. The distillation systems also feature computerized controllers that maintain optimal temperature and pressure for separating ethanol from water with minimal energy loss. The distillation columns are equipped with pressure and temperature sensors to keep the temperature within the necessary range, around 172 degrees Fahrenheit for ethanol. The heat generated during distillation is used to preheat other batches or to maintain temperatures in other parts of the plant. And finally, after distillation and several other processes, we obtain bioethanol, a unique biofuel made from sugarcane. The primary industry where bioethanol is used is transportation. In the United States and Brazil, ethanol is blended with gasoline to reduce greenhouse gas emissions and decrease reliance on imported oil. There are several main types of ethanol fuel blends. E10 is a standard fuel containing 10% ethanol and 90% gasoline. It is widely used in the United States and can be used in most vehicles without the need for engine modifications. E85, on the other hand, is a blend containing up to 85% ethanol and is used in specially adapted vehicles known as flex fuel cars. Ethanol made from sugarcane has significant environmental advantages over fossil fuels. Since sugarcane absorbs carbon dioxide while growing, bioethanol can reduce greenhouse gas emissions by 70 to 90% compared to gasoline. Additionally, ethanol fuel blends help reduce harmful pollutants in exhaust gases, such as carbon monoxide and benzene. Let's not forget the economic benefits as well. Bioethanol creates a substantial number of jobs in agriculture and industry. In both the United States and Brazil, the ethanol production industry provides hundreds of thousands of jobs. At the same time, the automation of production and logistics processes helps lower the cost of ethanol production, making it competitive with gasoline. The price of bioethanol varies by region, but thanks to technological innovations, its cost is gradually decreasing. Every day, over 100,000 bottles of ranch dressing make their way to store shelves. But did you know that producing this requires 22,000 pounds of dairy products per shift, with pasteurization occurring at 161 degrees Fahrenheit for 15 seconds? It's more than just a sauce, it's an entire industry. Let's break down how the world's most popular dip is made. The main ingredients of ranch dressing are dairy products, vegetable oils for mayonnaise, and fresh or dried spices. Every batch of raw materials that arrives at the production facility undergoes lab testing to ensure purity, freshness, and compliance with chemical and physical standards. Dairy products are tested for fat content, which should be around 10 to 20% to achieve the desired consistency, and for bacterial purity. Spices are analyzed for their essential oil content, which impacts the flavor. Manufacturers often use enterprise resource planning systems to track and control the origin of each ingredient. This ensures full transparency. For instance, if a batch with quality issues is identified, the system can trace the source and exclude it from future shipments. The production line is equipped with sensors to verify ingredient identity, and every batch is scanned and automatically inspected. Companies purchase raw materials in large volumes, such as 10 to 20 tons of buttermilk per month, ensuring a steady supply for production. Ingredients that do not meet quality standards are automatically rejected during procurement through automated systems that filter batches based on specific parameters. The system calculates the exact amount of ingredients needed based on the planned production volume. Software tracks the usage of each ingredient, helping to prevent overuse. Additionally, the automated purchasing system allows manufacturers to secure bulk discounts, reducing overall ingredient costs by 3 to 5%. The first step in the process is the receipt of raw materials, where both speed and precision in quality control are crucial. For instance, a typical ranch dressing production line processes up to 22,000 pounds of dairy products and up to 11,000 pounds of other components, like mayonnaise, spices, and oils in a single shift. ERP systems automatically log every batch of raw materials that arrives at the facility. Each batch of buttermilk is identified using a QR code or RFID tag, which contains detailed information about its origin, expiration dates, and certifications. Once received, the raw materials are sent to the lab for rapid testing. A milk analyzer measures fat, protein, and moisture content in under 5 minutes, with an accuracy of 0.1%. To check for bacterial contaminants like E. coli or Salmonella, modern PCR, polymerase chain reaction, analysis systems are used, delivering results in just 2 to 3 hours. Previously, this kind of testing could take several days, but automated systems now dramatically reduce the time, ensuring quick and reliable quality control. Impressive! Most ingredients undergo mandatory cleaning and sterilization before mixing to remove impurities and eliminate microbes. Fresh spices like garlic and onions are cleaned using infrared sorting machines, which detect and remove spoiled or rotten items with an accuracy of up to 98%. Other spices also go through infrared or steam cleaning processes. Buttermilk and sour cream are pasteurized to kill any pathogenic bacteria, ensuring they meet the highest safety standards. You've heard about my love for other foods, so now it's time to reveal my secret weapon in the culinary world. Let's just say, cooking isn't exactly my strong suit. I'm one of those people who can turn a simple Sunday barbecue into a game of find 1,001 ways to fix this terrible flavor. Take my burgers, for example. Not only did I oversalt the patties, but I also added super spicy pickles for a little kick. It was such a disaster that I was ready to grill a whole new batch. But then I decided to give ranch a try, and it worked. Turns out, this sauce is a miracle worker. It tames the saltiness and adds a creamy, mellow flavor that even saves my culinary mishaps. Alright, I think it's time to get back on track. The best part is just about to begin. Once all the ingredients are prepared, they are automatically fed into the mixers. Conveyor lines and automated pipes are used to transport the ingredients, ensuring that each component reaches the mixer without coming into contact with air or any foreign substances. For the production of ranch dressing, specialized high-speed mixers are utilized, capable of handling large volumes of ingredients in a short amount of time. For instance, mixers equipped with spiral blades can process up to 3,000 pounds in one batch, ensuring the even distribution of all components. These mixers are also fitted with sensors to monitor the temperature throughout the process. The temperature is maintained at 36 degrees Fahrenheit, which helps preserve the product's flavor and texture. If the temperature rises, an automatic cooling system activates to maintain optimal conditions. Depending on the recipe, the mixing duration can vary from 10 to 20 minutes. The system automatically adjusts the blade rotation speed, direction, and timing for each ingredient. For example, spices are added after the first minute of mixing to prevent them from settling. To ensure even distribution of the components, sensors measure the sauce's density and viscosity every 30 seconds. Ranch dressing must be thick enough to remain stable during storage. An integrated analyzer checks the viscosity of each batch, with an accuracy of up to 0.1%. If necessary, the software can adjust the mixing time or intensity. Additionally, the potential of hydrogen pH level is measured, as acidity is crucial for both the flavor and stability of the product. Ranch dressing typically has a potential of hydrogen pH range between 4.2 and 4.4 to achieve the optimal balance of taste and preservation. The system automatically monitors acidity and can add pH regulators if deviations occur. Before pasteurization begins, ranch dressing is transferred from the mixing stage to specialized pasteurization tanks through sealed pipes, minimizing contact with air and preventing contamination. These tanks are equipped with automatic sensors that monitor the incoming volume of sauce and calculate the optimal amount for pasteurization. The pasteurization process for ranch dressing requires strict control of temperature and timing to effectively eliminate pathogenic microorganisms while preserving the product's flavor. Typically, the high-temperature short-time method is used, where the sauce is heated to 161 degrees Fahrenheit and held at that temperature for 15 to 20 seconds. The primary equipment used for pasteurization is a plate heat exchanger, which enables rapid heating and cooling of the sauce through thin metal plates. Thanks to the large surface area of the metal plates, heat is transferred very quickly, minimizing the time the sauce spends at high temperatures. This allows for a processing speed of approximately 800 gallons per hour, a highly efficient rate for industrial sauce production. After pasteurization, it is crucial to cool the sauce quickly to prevent bacterial growth and preserve its flavor. This is achieved in the cooling sections of the heat exchanger. The sauce is cooled to below 40 degrees Fahrenheit within seconds. Rapid cooling inhibits bacterial growth and helps maintain the natural taste of the ingredients. Before packaging begins, the sauce is transferred from the pasteurization stage to specialized intermediate storage tanks. Each tank holds between 500 and 1,000 gallons and maintains the sauce at the required temperature. Depending on the order, the sauce is packaged into bottles, pouches, or containers of various sizes. The production line is equipped with multifunctional dispensers that ensure precise portioning. Depending on volume, the line can fill up to 500 bottles or containers per minute. Every package filled with sauce undergoes an automatic sealing process to ensure airtight closure. For bottles, specialized capping machines are used, capable of screwing on up to 300 caps per minute. For pouch packaging, heat sealing machines create secure, airtight seams. Temperature and pressure are automatically monitored to ensure the packaging is strong and durable.